Okay, determining a possible restriction, so the domain of this, so the inverse is a function. Okay, so when I think about this, I know it's a parabola that is left 3, down 4. And its slope is 1, so I'm doing a 1 over, 1 up, a 2 over, 4 up, so that's kind of the idea of my parabola. Okay, now I can either, because this doesn't pass the horizontal test, it's not going to work. So you're either going to have to take this half or this half, so that if you don't graph that, it would pass the horizontal test. Or if you were not to graph that, it would pass the horizontal test. So at x equals -3, you're either going to go that way or that way. So this would work. Given this equation, write the inverse. So this is the first y, so I'm going to now replace it with an x. And this is the original x, so I'm going to replace it with a y. Now I'm trying to solve for that y. So x plus 6. Now I'm going to divide by 2. Okay, that's my new equation, except for instead of y, I'm going to write it as the inverse function equals okay, number 3. So given these, state the domain of the resulting function after it's reflected over y equals x. So that means the inverse. So that means my x and my y's would get switched. So the domain of this, the domain of this new would equal the range of the original. That's the idea, right? The x's and y's get switched, so the domain of this would be the range. So the range is that. So I'm going to write them as a set of values because it's not from this to this. It's just specifically those 3 values. Given this, verify the inverse equals the original. So this is the original y, so now I'm going to make it the x. This original x, I'm going to make it the y. So I'm going to subtract 4, and then I'm going to divide by -1. So x minus 4 over -1 equals the new y. And I'm actually going to divide that by -1. So -x plus 4 equals, and I'm going to call this that. So -x plus 4, that's the new function, and the original was 4 minus x. Are those the same? Yes, because -x, -x, and a plus 4 and a plus 4, they both have the same. So given this, for x is less than or equal to -1, write the inverse. Why did I have to do that? Because this is a parabola, shift it left 1. And that's that. But the domain is that way. So just this. Okay, so I'm going to do the switch. So this is the y, so now it's x. And now this is a y. So I'm going to square root. So once I do that, it gets rid of that. And so think about when you square root, this could be plus or minus the square root. So on this one, I'm going to want the negative because I'm taking the left half. And then I'm going to need to minus 1. Okay, but I would like to write it formally here, how it says. Oops, I forgot the negative there. So negative root x minus 1. Determine one possible restriction for the domain. So the inverse is a function. So this is a right one shift on a parabola. So you either have to take this half or this half, so that when you take that half, it's going to pass the horizontal, so the inverse will pass the vertical, or you could be taking that half. So either we could go x is less than or equal to 1, or x is greater or equal to 1, which is also that, and this one is also that. Okay, given this, evaluate. So I'm going to do the switch. So x equals negative 3y plus 7. That's the switch. X minus 7. Divide by negative 3. So the new function equals x minus 7 over negative 3. And now I'm going to input a negative 2. So negative 2 minus 7 over negative 3 equals negative 9 over negative 3, which is 3. Number 8. So when you see something saying a reflection, it means inverse, which means the xy becomes yx. So if we switch those around, we will get A. Given this graph, so that's a right 2, as you can see, determine one possible restriction. So the domain, we're either going to have to take this half or this half in order for it to pass a horizontal line test. So we could go x greater or equal to 2, or x is less than or equal to 2. And then this would also be written if you want it in that form. Oops. Given this, determine the equation of the inverse. So I'm going to switch this with an x, and I'm going to switch this with a y. Okay, so I'm going to do a cross multiply. Then I'm going to add 1. And then I'm going to write it formally. Okay, number 11. We are given that we need the new equation. So I'm going to switch this y. This is y, so I'm going to switch it with x. Just put the x, I'm going to switch it with a y. To solve, I'm going to subtract 2, and then I'm going to divide by 3. And then obviously this is now, instead of y, I'm just going to rewrite it with the inverse. So that matches D. Describe how to determine the range of the inverse. So the range of the inverse would equal the domain of original. So describe, you can say the range of the inverse would equal the domain of this original graph. Explain why the inverse of this graph is not a function. Okay, so this graph will not pass the horizontal line test. So that's a fail. The horizontal line goes through 2 points or more. Thus, the inverse will not pass the vertical line test. Thus, it will not be a function. Okay, if somebody wanted to actually graph, for instance, 0, 2 would become 2, 0, negative 3, 0 would become 0, negative 3, 3, 0 is now that. Let's go negative 4, 1 would become 1, negative 4. So this would be a sketch, and then you can see that you get a vertical line that fails. Okay, your x values can't have more than one y value. Identify the graph of the inverse if that is happening. So what do I know about this? If I was to ever just graph that function, a parabola that's shifted down 9, but I want the domain of just this half. So this point is 0, negative 9, and if we go over 3, up 9, this coordinate should be 3, 0. So the inverse would have a 0, 3 and a negative 9, 0 on it. So looking for those two coordinates, it would be this one, D. Determine algebraically if those are inverses of each other. So if I make this y an x and this x a y, to solve I'm going to do a cross multiplication, and then I'm going to subtract 5. If I wanted to put this over a common denominator, I would do 1 over x minus, I need an x, which makes that a 5x. So therefore, that and that are not the same. They're not the same. Okay, and you could have tried to go from there back to there as well. Given the domain of f of x and the range of that, state the domain of the inverse. So the domain of the inverse will equal the range of the original. So the range of the original is this. So your answer should just be writing that out. Domain of the inverse is, so the x values of that will equal the y values of that. Sketch the graph of the inverse. So I'm going to grab some points here. 1, 2, 3. -3, 2. -1, 4. 1, 4. And 2, 2. So I need a 2, -3. I need a 4, -1. I need a 4, 1. And I need a 2, 2. That one will stay. And then I have to think about the connection of these and the direction of the arrow. Determine the equation of the inverse. So this y becomes the x, this x becomes the y. I'm going to subtract 9. I'm going to times by 4. Which would be, if I wanted to do that, 4 times it. And now I'm going to divide by 3. So you can leave it like this on that side. Or we're going to simplify that. So I will do f of x. So 4x minus 36 over 3, that's fine. I'm going to go 4/3 x minus 12 to simplify it. Okay, so I divided each term by 3 because it's just that's how we graph lines. Given this point, state the coordinates of it after it's reflected over the diagonal line. So that means to switch the x and y. So 1, 5. Determine the equation of the inverse. So this y becomes the x, this x becomes the y. I'm going to subtract 4, and then I'm going to divide by 3. And we're going to write that as the inverse of f. So x minus 4 over 3. Number 21. You have your original function with a domain and a range. Identify the domain of the inverse will equal the range of the original. So I need that as my answer. We have a function that has a domain of that, range of that. Identify the range of the, so the range of the inverse will equal the domain of the original. The range of the inverse is the domain of the original, which is that. So D. Sketch the graph. So this is the inverse. Again, same thing. So I'm going to grab some points. 1, 2, -5, 3. We'll go to 1, 2, 3. -5. 1, 2, 3. -4, 1. We'll go to 1, -4. And we have a 1, 2, 3, -3, -1 will now go to -1, -3. -2, -3 will go to -3, -2. Two will stay. Oh, no, it won't. Sorry, that is not, what am I doing there? That's the wrong coordinate. That is a -1, comma 2. We'll go to 2, -1. 0, 0 will stay at 0, 0. Okay, so how do we connect it? So this will have to go there, there, and then this had a arrow on it.